Go.
Today, today I'm going to be talking about the difference between caller and callee saved registers. Um, so yeah, a lot of people are confused by this topic like the first time they see it, but with a little bit of practice, it's really not too tough a concept. So I guess I'll start by explaining why it's important to save registers to begin with. And the reason is that hardware has like a finite number of registers, and multiple functions could be trying to access those same registers, and you need to basically ensure that those two registers or those two functions don't mess each other up. So if you look at this basic code here, it's pretty simple. Main's just declaring three variables. Then it calls foo, which doesn't do anything particularly interesting. It just sets two variables, and then the main does some calculations, and then it returns. So say we have the following variable to register mappings. So A is mapped to register 1, B to register 2, C to register 3, and then D and E, which are foo's variables, D's mapped to register 1, and E is mapped to register 2. So if we were to run this code, what would happen is we'd get a 1 for A in register 1, a 2 in register 2, and a 3 in register 3. And then foo would get called. And if we're not doing, saving any registers, foo is just going to go ahead and it's just going to overwrite these registers with its own values, and then it's going to return. And then when we get back to main, and execute this line, c equals a plus b plus c, it's going to go to register 1 looking for the value of a, and there's going to be a 4 there, and there's going to be a 5 for b, and a 3 for c, and so c is going to get set equal to 12, and this is going to print a 12, when clearly c should be 1 plus 2 plus 3, which is 6, and so this code should print a 6. So that's why we need to save registers, basically. So as for the difference between caller and callee saved, in caller saved, the function doing the calling, in this case main, is responsible for preserving its own or saving its own registers. So main essentially assumes that foo, the callee, is going to change every register, and so anything that main cares about, it needs to save. So in this case, main needs the registers for A, B, and C to do this computation. And so before it calls foo, it needs to save all of those values. And then after foo returns, main needs to restore those values before it carries on. So yeah, in caller save, like for this specific example, we get one load and store associated with A, B, and C. As for callee saved, so the thing being called, in this case foo, is responsible for maintaining the state of the registers when it's called versus when it returns. So essentially foo would assume that main needs the state of all its registers preserved. So anything that foo is going to modify, it must first save and then restore at the end. So in this case, there would be a 1, 2, and 3 in these three registers at the beginning. Foo is going to modify registers 1 and 2, so it would need to save the values in those registers when it's called. Then it can use them however it wants. It can put the 4 and 5 in there, and then right before it returns, it needs to restore those registers to their previous state. And so for this code, if we're counting number of loads and stores, if we're looking at caller saved, A, there would be one load store pair, B would have 1, C would have 1, and then D and E would have 0 because foo doesn't call anything. Looking at callee saved, so foo's the one doing the work, so there'd be no loads and stores associated with A, B, and C, and then there'd be one for D and E. And just one more thing I want to mention that applies specifically for caller save. So I already mentioned that the caller only needs to save the registers that it cares about. So say instead of C equals A plus B plus C, we just have C equals A here. So when main calls foo, it now no longer needs to save the values associated with these variables B and C, because it doesn't actually use them down here in the code. So foo could change the value of register 2 and main wouldn't care. And foo could change the value of register 3 and main wouldn't care, because C is just getting whatever values in register 3 is just going to get overwritten here. So the only thing it needs is the value of A.